Now let's practice solving power equations using a two-column table. I'll do the first one, and then there's a few for you. In this case, I have two operators, squaring and adding. Squaring will be first, and adding will be second. So I'll need two rows. I'll square first and add second. Here are my inverse operators. I'm making sure to include both answers when I take the root, both the positive and the negative. So I start with the original. I start at the bottom of the right column. I subtract 1 from both expressions and simplify. I move up a row. I find the square root of both expressions, again, taking into account there'll be two answers, a positive and a negative. I simplify and find my two solutions are positive and negative 3. Last, I'm going to check my work, so I'm going to use 3 in this case. Substitute and simplify, and sure enough, my values are the same, so I'm comfortable with my solutions. Try this one. Again, we have two operators. Power will be first and subtracting will be second. So my left column will have power and subtracting. I'll then, in the right column, build my inverses. I don't have to worry about a positive and negative because the index is odd. I only have to worry about that when the index and therefore the power is even. I'll start with the original. I'll start at the bottom of the right column. I'll add 18 to both sides and simplify. I'll take the fifth root of both sides and simplify. I can't simplify this any further because 20 is 2, 2, and 5. And the only way to get out of a fifth root is I would need 5 factors that are the same. And I've only got 2 that are the same here. To check my work, I return to the original and substitute. The fifth power undoes the fifth root, and I'm left with the radicand. And then I simplify, find my values are the same, and I'm comfortable with my work. Here's another. This time we have 3 operators, squaring, multiplying, and subtracting. So in the left column, we'll have our squaring first, multiplying second, subtracting last. Here are the inverses. Again, since my exponent is even, I'll need to account for both answers. I start with the original. I start at the bottom of the right column. I add 23 to both expressions and simplify. I move up a row, divide both sides by 2 and simplify. I move up a row, take the root of both sides and simplify. And then I need to recall my previous work that the square root of 12 should be written as 2 square roots of 3 because 12 is 4 times 3. Returning to the original and substituting by the power of a product property, I know to square both factors in the parentheses and then simplify to check my work. Here's another. Again, there's going to be 3 operators. First, I'd find the 7th power, then I'd subtract, and last I'd divide. Here's my left column. Here are my inverses. I start with my original. I start here at the bottom of the right column. Both expressions are multiplied by 11. These 11s will reduce to 1, and I'll simply have the 7th power of k minus 6. Of course, on the other side, I'll get 33 when I multiply. I'll move up a row and add 6 to both expressions and simplify. I'll move up a row and take the 7th root of both sides and simplify. Here's my answer. I return to the original and substitute my answer. The 7th power undoes the 7th root, leaving me with 39. And then I simplify to find the left side is 3, just like it needs to be. Try this one. There's a little bit of work with your final answer. We have three operators: squaring, dividing, and subtracting. Squaring will be first, dividing second, subtracting last. Here are my inverses. I start with my original and add 1/10 to both, because that's what the bottom of the right column tells me to start with. I then simplify. I move up a row. I multiply both expressions by 5. The 5's will reduce, leaving a k squared, and here they'll leave a 1/2. I'll move up a row, take the square root of both, keeping in mind I need both the positive and the negative answer. I simplify. Last, I'll need to simplify this root. Remembering my rules, the square root of a quotient can be written as the quotient of the square roots. Square root of 1 is 1. I now have an irrational denominator that I need to simplify through rationalizing the denominator. I multiply by 1 in the form of root 2 over root 2, and that will give me square root of 2 over square root of 4, and the square root of 4 will just be 2. Here's my final answer. And here's our last one. For this example, I have three operators. I'll find the fourth power, I'll add, and last I'll divide. Here's my two-column table. I'll start at the bottom of the right column and multiply both expressions by 6. On the right, the 6's will reduce, leaving x to the fourth plus 28. On the left, I'll get 60. I'll move up a row and subtract 28 and simplify. I'll move up a row and take the fourth root of both expressions, remembering to find both the positive and negative answers. And then I'll simplify. Last, I'll try to simplify my root. 32, if prime factored, is 5 factors of 2, so that can be written as 2 to the 5th. Then for the base of 2, 4 goes into 5 once with a remainder of 1. And here's my final result. Well, that concludes this video, where we've solved some power equations using a two-column table.